you, Meg. All right, look. I need your attention, please. Thank you. Let's take it back. Something simple that you might remember from ninth grade. If you don't remember, that's fine. Hopefully, I got you. You're going to take a few notes here. Okay, please stop talking. A blank is a set of ordered pairs. Well, in math, we call a relation a set of ordered pairs because they show the relation between one variable to the next, the relation of our inputs to our outputs, the relation of our x values to our y values. A relation is simply a set of ordered pairs. Ordered pairs can show input values and output values. Your input values are your x coordinates, and then the output values are the y coordinates. Two ways that you can show me a relation is by using ordered pairs, writing the x and y, or by using map diagrams. Look at what you got below. And then you're ready. On this side, it says you're going to write the ordered pairs that are represented by the mapping diagram. That means when you look at the mapping diagram, what do you see mapped with what? What input matched with what output? Okay, I heard it. -6 is matched with -10. What else? Thank you. 2, -8. Thank you. 0, 5. 1, -5, and perfect. Those are your input matched with the output. What if I reverse it? If I give you the ordered pairs this time, and I want you to put it in a mapping diagram. Okay, we want to go from smallest to biggest on our input column, and thankfully it's already written that way. When I say smallest to biggest, I mean 0, 1, 2, and then 3 in order. And for our output values, we write those down and map them accordingly. Surprisingly, they just actually map straight across. No crisscrossing around. There you go. Those are relations, simply put. Now, if I take a relation up a step, a function is a relation where every x value has exactly one y value. In a function, none of your x values can repeat. I won't say x's, I'll say x values. Okay, so you may remember the example that me or Miss Buffer gave you with the girl and the boys and the x value and the y value. Remember? Based on, think about biology, right? In biology, girls have the x chromosome, guys have a y. Okay, so basically what this is saying is, if these are my girls, these are my boys, my girls don't need to have more than one boyfriend. Okay.
Wait.
So let me, oh gosh, I shouldn't say that. If it's a function, your girl here can't have more than one boyfriend. So it can't be paired with more than one y, just one y each one, okay? Now this is totally a genderless thing because it's okay if the y value has more than one x value, it's still a function. But it's not a function if the x value.
The x can't have a lot, but the y can.
Correct. The x can't have but one. So like, based on this first one here, if this is a function, then that means your x values can only have one y value matched with it. Is it a function? You sure?
Yes.
It actually is. Because see, this only has one, -3. Y'all, please look. This only has one. But this is where you probably got confused. Because you see 9 goes with -3. Sadly, that's the boy being shy of the girl because he's got 2 different ladies. But you get what I'm saying.
Wait, so he can have 2 different ladies though? That's
Oh, God.
Okay, so in math, yes, but in real life, that's not.
No, that's what I'm saying, like in math. Like,
Yeah, in math, yes.
so
In math, you
so
are shy
1, 9 can have both have the -3, or -3 can both have 9.
and 0. Yeah, because 9 and 0 are both paired with the 3. It's still a function. but it wouldn't be a function if your X values paired more than one time. I hate that so much. Look at the next mapping. On the next mapping, this time, what do you see?
9 is going with -5 and -9.
Yeah, okay, so this is a problem right here,
And 15.
and 15 is a problem. Okay, so both of those are problems because you cannot map with more than one value, so this is not a function. Remember when I told you about your X values? If I'm not looking at a mapping, then I'm simply looking to see, do my X values repeat? Look at your column here.
Yeah, could we just say?
Yes, -2.
Yep. Since these values here have repeating X values, it's not a function. Now, this is telling if it's a function by mapping and by order pairs. If I give you a graph, you can tell if a graph is a function or not by using the vertical line test.
Is that the pencil?
Yep. In the vertical line test, you would draw a vertical line through a graph. And if it touches 2 or more points, it's not a function. If it touches 2 or more points, it is not a function. So we're going to use the vertical line test to determine if the graphs below are functions. I took the liberty of putting lines on here, vertical lines, see? So for the first one, number 10, notice if I pass this vertical line through, will it pass through more than one point vertically? No, you got it. So that means it is a function. So number 10, the first one underneath is a function. What about the second one?
No.
Okay, this one's not a function, good. Because it's gonna pass through every time you slide it across. What about the last one?
Yes.
Good job. Nicely done. What I want you to do now is do the back side right quick on your own. And then I will show you if you're right or wrong. No, the back side, I'm just gonna go ahead and give you a heads up. I took one of the questions and made it on the X ticket. So, actually try it.